welcome to the YouTube channel. I think this is video 205. We've got a Trend IQ3 faulty controller on a site, and we've got 240 volts power to it, but there's no response. It's not working. So there's 240 volts here, but this controller is not working. It's faulty. Now, I think this controller, from the sheets that I've seen that I got the engineer to send me, I think it was installed in 2012, and then another company came in 2017 and made some modifications to the drawings. In 2012 there was a flue fan and for the boilers, and I think the boilers got changed out in 2017 and there was no requirement for the flue fan, so modifications was actually made in 2017 for this system. It's quite a simple system, there's not a lot of I/O, and if we go through the panel front, well, inside the panel, sorry, of what the engineer took for me, you've got the IQ3 controller here, which is not responsive. We've got some relays here. Let me just zoom this a little bit further in. So we've got gas detector, gas leak detection there. We've got some 24 volt relays here. We've got some 10 volt SRM relays here. That relay 4, there's no output coming from that, so that's currently a spare, or the output hasn't been wired. We've got some CT current transformers here, 1 and 2. So we've got the live cable wrapped around, and when there's a current through this will actually switch and let the IQ3 know that the pump is running. And the same with this one as well. I think one's for the heating pumps and the other one is for the domestic hot water pumps. We've naturally got the MCBs here. We've got a common bar in at the bottom here with the 240 volt supply, and this will be, I should imagine, our 24 volts from our transformer to the field controls and also the relays in here. It won't be them are 10 volt relays, so we're using an analog output to energize them via the Trend. These are the outputs of the Trend here. And then we've got, it says a DIX module there, but that's not a DIX module, that's a DIX module here. And then we've got another DIX module here. And then we've got RO2 modules, the 2 relays basically. And what you do there is you give it an analog signal of 0 to 10, and it, depending on the jumper settings of these relays, I'll show you a little bit more about these in a minute. You've got raise and lower, so that would be for a valve, and you've got high and low, so that would probably switch a pump on, and then after the pump's running it will switch the boiler on. So you give it 5 volts to switch the pumps on, you give it 10 volts it switches the boiler on. This is slightly different, the raise and the lower. This is where 7 volts is not raising the valve, 4 volts is lowering, 10 volts is raising the valve. But we can look at that later in the logic, so we've got to write logic for them. Not sure what all these relays are. They've got 0 volts attached to them all on the coil, and then they've got different numbers there that are basically energizing these relays. I presume it's field equipment to let the control system know whether it's on or off, like safety, emergency stop, etc. Now, I went through all the I/O on all the drawings. Let's get back to the drawings. I think it was on page 9. So this is the I/O of the drawings of the controller. So we've got some inputs here, outside air temperature, boiler flow, boiler return, hot water, space, and according to that they are spare, which I think is not the case anymore. So this is the old one. This is a 2012. Let me pick up the IO for the other one. So it's going to be maybe page 8 here. Yes, so this is the IQ3, and if we look at the IO for this, outside air, header flow temperature, heating flow, return, space, cylinder 1, cylinder 2, heating return temperature. Sorry, that was heating flow temperature. And then we've got an RL, so raised lower, heating pumps 1 and 2. I don't know whether that should be, that's normally binary. But anyway, that's what it's set at. It's got an RL, which is normally raised lower. But normally that, I think that should just be binary. You give it to 5 volts, it puts on heating pump 1. You give it 10 volts and it puts on heating pump 2. Heating pump 1 goes off, but we'll see. 10 volt relays, 10 volt DC, override and boiler 1 enable, high low, boiler number 2 and domestic hot water pump. So I presume that is putting the domestic hot water pump on first at 5 volts and then puts boiler 2 on, which is doing the domestic hot water at 10 volts, and then a couple of more, that's 10 volt DC relays, heating override valve, so that's operating a valve. And this one, which isn't connected on the drawing, is remote alarm enabled, so there's no remote alarm. So we will still put it in the logic, but we know that it's not going to go anywhere because it's not wired in as of yet. Right, so that is that. Let's just show you some of the equipment. So this is a 4-channel digital input multiplexer. So what we have here is we have 4 individual inputs coming in at the bottom here, 1, 2, 3, 4, and we have 24 volts AC or DC supply to it, and then we have a signal coming back to what used to be the IQ3 to say what inputs are actually on, so that we can actually control the system. So you've got 4 inputs going actually into one universal input. The gas detection unit that's in there, which is a simple sensor that's attached to it and it's sending out an alarm back. This is your 10 volt DC relay, so that will work on an analog output. So if you, on a MAC36 for example, if you give it 10 volts, that relay will energize. I think there's a video previously showing you that. And the 2-stage relay module. So this is the binary, jumper, raise, lower, jumper, high, high and low jumper. I don't know whether you can see it. Yeah, raise, lower position, high, low position, raise, lower, binary position. 0 to 10 or 2 to 10, or you can actually, yeah, you got some overrides there. Anyway, you would have it in the auto position, so you wouldn't override any of them. You have it in the auto position. You use 0 to 10, and depending on the application, you've got 3 lots: binary, raise, lower, high, low. I don't know whether it tells you. Oh, you've got a data sheet there that you can actually download and look at that. Right, with that said, we need to start with the software. So first of all, I'll bring this across. I've already done, not the hard work, but I've already decided, and it's exactly the same as the IQ3, what points we're using. So outside air temperature UI01, so it's a straightforward exchange. UI9 for the DIX1 module, UI10 for the DIX2 module. So that's 4 inputs coming in there, but sorry, it's only 1 input coming in, but there's 4 digital inputs we are monitoring and 4 digital inputs we're monitoring there. So we've got the raised lower for heating pumps 1 and 2. So that's normally binary, so I'm not too sure how that's configured, to be honest. But it doesn't make any difference. My software, I can select raised lower, or I can select binary if I want to. There's no problem. Or high and low with the software that I would write. SRMO1 unit, so that's 0 to 10 volt DC, 0 to 10 volt DC again. High low for boiler 2, so that will switch on the domestic hot water pump first and then switch on boiler 2 once that's running and proved via our logic. And then you've got the 2 10 volt relays again there, and then you've got your Dix M1, which has heating pump status, so that would be the CT, yeah, CT1. Domestic hot water pump status, CT2, and then heating pump 1 fault, heating pump 2 fault. So we'll get them from the pumps. And then the Dix module 2, we've got our safety status, DIO1, and then hot water buffer tank 1 high limit, hot water buffer tank 2 high limit, and we've got smoke detector. Personally, if I'm using a MAC36, which I am, I would prefer to wire all these safeties, and all these 4 I prefer to wire directly into the MAC36 rather than using another module that can go faulty. But that's just me. So I think I will do it as per what we see, the Dix 2, but I may on site decide to wire, if it's not too far, the cables, if I've got plenty of room on the cables. If not, I can put new cables in, but I'd probably prefer to wire these 4 items directly into digital input 1, 2, 3 and 4 off the MAC36. So we've got, with the MAC36, we've got 16 UIs and we're only using 10, so that's good. And we've got 8 AOs and we are using 6 here. So again, that's good. We won't be using any of the 8 DOs, and we may use the 4 DIs if I decide to use to wire in this Dix module 2 directly to the MAC36 rather than using the Dix module. So that's it. So now we want to go to the software. So let me just put you on pause and load up that for you. So I'm loading up 4.8. The reason I use 4.8 is if I want to install the latest N4.15, I can from this software install it, commission and 4.5. But for example, if I wrote it in 4.15 and the engineer on site, if it's not me, has only got 4.11, that's a little bit more difficult. So it's better to do it the lowest version, for me anyway. Write the logic in the lowest version so that it can easily on site be sent to the engineer, and whatever version he's got, he's not going to have anything lower than 4.8, or he shouldn't have. He probably got 4.15 currently, but he may have 4.14 or 4.11. So it's just easier for them to take that file and load it in depending on what he's commissioned the station at. So we're loading this one up at the moment. It's taking its time. I'll just put you on pause. Right, that's loaded. So I've done a station, standard 192.168.1.123, and I haven't wrote any logic in this at the moment, but I have put, sorry, I haven't added the IO, but I have actually done some infrastructure of how we're going with this. So in the logic here, well, let's go to drivers first. Backnet we won't be using, but I've still done that, backnet over IP. So we've still set that up. In fact, let me just double check it. You won't get this link back operation, so don't worry about that. Let's just go AX backnet device. So there's nothing there on the backnet. And if we go into local device, device 1, and then if we go into our comms, network IP, it's disabled at the moment, let's just enable it. So Ethernet 0, save that, and then what you've got to do is right click it, actions, and enable. And that's working now. So backnet is now working on that controller. Modbus, we haven't got no Modbus devices. Well, let's go views, AX property sheet, and we're using COM1. I normally wouldn't use 9.6, I would go right to 115200. And 8.1 and none is normal, we would keep that. Bear in mind that if you was talking to some electric meters, they may use an even parity, but normally it's none, and sometimes they will use 2-stop bits, but because we're not connecting anything anyway, it's pointless me carrying on talking about that. And then the ISMO IO, let's just save that. So the ISMO IO is all here, and that's just your IO. So there are your 4 digital inputs, your 8 outputs, and your 16 universal inputs, and your 8 analog outputs. They're not named or anything like that, they're just as default because I don't name them. I have my own folder that I make for my IO, which is here under logic. And they're already connected, but that's it. I've not named any of these whatsoever yet, and the outputs are already connected, but I've again not named any of them, and I've got no logic going into them. I also added in a date and time. I always do that. We don't sometimes use it, but it's just a bit of logic that I wrote a long time ago, and it separates the time, mainly for graphics, the day, whatever, afternoon, so you can say good afternoon. And I've also got this in for the week number as well, taking the current time. If you want to know how that works, you're basically taking the current time and you're timesing it by 6048 and then 1, 2, 3, 4, 5 zeros. And then once you've done that, you take that and you take away 2921 to give you the week number. So we're on week 10, and we're the 3rd of the 4th 2026, and we're on week 10. 3rd of the 4th, that's wrong, isn't it? 4th of the 3rd, sorry. Yeah, March the 4th. Right, so back to this. The DIX modules. So I've got some DIX modules here where we will basically receive a voltage coming in, and depending on that voltage, the outputs will either be on or off. And these are the 2 DIX modules here that we saw. And then the relay modules, this is the raise lower, and this is the high or low. And if we go in here, you will see these are the signals, the 0 volts, 4 volts, 7 volts, 10 volts for the binary raise lower, high and low. And I would just select from here set, and I will select raise and lower, binary, or high and low. But I believe it's raise and lower for this one. And then in the logic folders, so those are your two inputs, this is your output. So I will basically, if I want that to be on, let's just do this. So we're in raised lower at the moment. So if I enable that, emergency active, I've got 4 volts coming out. If I turn that off, actions, emergency active, I've got 10 volts, and when they're both off, I have 7 volts. And this is the logic inside for that. So we've got an AND gate, an XOR, we've got some numeric switches there, maximum block, and we've got a main numeric override switch there to put it to 0. That is if you put both of them on. So let's just put both of these on. Actions, emergency active, actions, emergency active, and we've got a 0 there. If I look at the raise lower, there's a 0 because this is activated true, so it's bringing that 0 across into this switch. Let's just put that back to normal. Auto, the binary logic. So this is the binary logic. Depending on what input is required, we'll switch through whatever voltage, 7 volts, 4 volts and 10 volts, which is there for the, and then both of them off is 0 volts. And then the final one is high and low. We've got our 2 inputs into there again. We're reversing that NOT gate into that, and you've already seen it working anyway. So 0 volts there, 10 volts there, 5 volts there, and you can just pause this and you can actually copy this out. This is just the switch, which all we're doing here is the jumper switch in this folder here, and they're just equals in there. So we take the value coming from the enum, and depending on the value, if it's 0, we'll enable that. If it's a 1, we'll enable that. If it's a 2, we'll enable that. And that's your jumper, your raise lower. And this is what I've used. I've used a 0 binary, a 1 for raise lower, a 2 for high and low. So that's simple enough as well. So those are our components we'll be using, and then we've got to write some logic, which would do that in the wire sheet. But first of all, what I'm going to do is I want to put my points in from that sheet that I showed you. So I'm going to do that now and put you on pause. Alright, just got this one to do, and then that's it done. So AO6, this is the one that hasn't got anything connected to it, and on that it is remote alarm enable. Remote alarm enable. And that is it. So we're not using any of these digitals. We're not using currently these digital inputs here. So we've got outside air, header flow, heating flow, return, and then the DIX module 1 and 2. So we can actually link mark that now, DIX module 1, and I can go into my logic here and link from out into there. So depending on the voltage that I get in, I will have these, which is, rename, DIO1 is heating pump 1, Omega. Di2 is domestic hot water pump status. Oops. Status. That's going to be pumps status. So we know we've got a pump running. Heating pump 1 fault. Rename heating pump 1 fault, and the other one's heating pump 2 fault. Rename heating pump 2 fault. And then this one, what I'm doing, I'm looking at my other screen because I've got this on my other screen. So we're now doing safety status. We're doing this here, safety status, HW buffer tank 1 high limit. Move that across. Rename safety status. Rename buffer tank 1 high. So HWS buffer. I don't need to put 1 high limit. Take that, Control key C, rename buffer 2 high limit, and that one is smoke detector alarm. Smoke detector alarm. Now I would expect these to be, in fact, let's just put the link mark that, and I can just click on that to go back to the folder that's in, and link to out from there into there, and then follow it back through again to get to that page. I would expect false to be healthy and that to be alarm, because I've already looked at the drawings, so I do know that already. And that is also the same, but instead of alarm we'll do cutout, exclamation mark, and we'll put a hyphen as well there. And then this one is also going to be the same. We need to put alarms on these, and that is fail safe, so that is safety and healthy. Save that. So that should be an alarm, and these, you can do these. This is healthy, and this one is fault. Save. And we can do the same there. Now this one is not going to have any alarms on at all. This is stop or run. It's not a DP So it's not really a, I can't do flow and no flow because there's no differential pressure sensor. They're just CTs that's wound round, and it's just monitoring the current. Right, so that's them done. We don't want to do anything yet with the relay modules, but what we do need to do is put some alarms on here. So let's go to the alarm palette. Okay, I'm just going to use my left navigation bar and expand that a bit more. And then I'm going to take my alarm extension and Boolean change of state and drop it into there, leaving it as exactly as it is. I'm not going to rename it in any way whatsoever. And this is, in fact, I'll cover it for all of them. Issue, healthy, and fault. I'm not bothering with anything else, and it's going to be when that gets into an alarm, correct. So I'll take that now, I'll copy it, I'll paste it into that one, paste it into that one, and paste it into that one, but this one I need to reverse it. So I don't want the alarm on healthy, I want the alarm on safety. But I'm going to take another one of these, copy it, and paste it into that one, and paste it into that one. What I'll do as well is I'm going to put some histories on these. The histories will already be in the alarm palette, in the alarm system if you go into it, but I am still going to put on all these a Boolean change of value. So we've got a history on that one, and that's set probably to 500, which is normal. We can stay that, yes. And I'm not going to bother enabling them yet because you don't want to. You can enable them all in one go. So I'm going to copy that, paste it into there, paste it into there, paste it into there. Also paste it into these here as well. Paste, paste. So that's the histories done. I've already added histories on these points here. So we've got numeric change of value history there. So these that we're not using, I can either leave the histories there and don't bring them in, so I'll leave them there. Let's go to our services and our history service, and I'm not interested in them histories, but I want anything that's got text along there, so we can enable them. And I can enable them. And those digital inputs, I can enable them. So that's the histories done for all the main points. Yeah, I'm happy with that. So now I need to start writing the logic. Finals. I've got the relay modules there. That is me putting pump 1 on, pump 2, domestic hot water pump, boiler. And then we've got how many safeties? Just one safety? We have, haven't we? So I don't need these at the moment. So wire sheets. Saying I don't need them, I need to know what we have got in the IO. So we have an outside air temperature sensor, and we've got the buffers there for that, but our only safety we have got is from here, which is just that, and smoke alarm. Well, if there's smoke, there's a fire, so we don't want anything running. So them two there we need. Okay, so let's make a new folder. Let's just call it safety. And because I've already got them here, I'm just going to take them from there. I only want that and that. Copy them, paste them into there, but I don't want to have in there now the history. I don't want to duplicate my histories. So I'm going to, when I find it, go into both these, take them out of the way, and take them out of the way, because we don't need more than one. And then I'm going to take out, that's because I've got them both highlighted, I'm going to take out all that. Safety status, smoke alarm. So we would expect for safety to be on. So let's go and put our safety on at the moment. Actions, emergency active. And we need to also just take another one of them, duplicate it, and safety out. Just coming out of this folder. And then we will put a NOT gate in. We need a NOT gate. So that's got to kit control and logic. And let's get a NOT gate. Put that into there. Like so. And then we need an AND gate. Move that across there. We're going to put that into there and that into there. That's our AND gate, and that's our safety coming back out. Now we're going to composite these points to the folder. So I need to get, that's the safety there. Right click it, composite. So we've got safety status, so that's in 10 coming in. Smoke in 10 coming in. And safety going out. Okay, so that's put the nibs on there and there. We right click safety, we do views, and we do AX slot sheet. And we'll put that to safety status. Let's use some capitals in here. And that is smoke detector. And that was safety healthy. Go OK to that. Look at the wire sheet. We'll link mark it. And and we have smoke detector link to, out from there into there, and safety link to, out from there into there. So that's the opposite way round, because that's healthy, that's healthy. So that needs to say healthy. So true is healthy. That's not healthy. Save that there. Which is glad I've done it that way, because I can show you now. You will see once I click on this nib that it will be wrong in the folder. See it saying alarm there? So what we do there, views, AX slot sheet, and this is the one here that we need to change. Oops. Right click it, facets, and I can change them there, but because I've already got it somewhere here, there, because I've already changed it previously, that's now saying healthy. So true is healthy. So that's our safety. So that's our start of our system. Now I presume we would need a time clock for when they want the heating on, and a time clock for when they want the heating, the hot water on. And I presume because they've got outside air temperature, they want to also stage the boiler set point with the outside air. So if it's hot outside, the set point wants to be lower than if it's cold outside. So what we will do here then is we will put another folder, I think, new folder, and I don't know what to call it yet, but we'll just do I'll just leave it a folder at the moment while I work on what we need to put in there. So we need our outside air, and we also need our space temperature, because we want to know that it's not too cold in there. So we definitely need them too. So let's take our outside air and our space temperature, copy, paste it into this folder. Again, take out any histories. So into there, take out that, and take out that. So I can rename this just to outside air, and our space temperature. Right. So now, depending on the outside air, we want to change the set point for heating. So we need a heating set point. So duplicate, and heating set point. We'll put that over there because that's our outputs. And domestic hot water is going to be the same regardless of the outside air. So we don't want anything there on that one. And we don't need to stop anything. We don't need the safeties. This can still calculate regardless of whether we've got a fire alarm or anything. It doesn't make any difference there because we're not switching anything on as such. we're just making some calculations. And then the space temperature, we could use that for fabric protection, so that if it gets too cold, we can basically enable the heating if required. But we normally do that when the time clock's off. But in order to do that, we would no, we don't need. Space temperature would normally go in with the heating system folder that's enabling the boilers. So I think I am going to take that out at the moment, and so this folder is going to be something like outside air compensation. So now we'll go into our maths, and we'll put a reset block across, and we'll call it heating SP. In fact, I don't want to put SP at the end because I've been searching probably for SP, so I'll just put it as heating temp, heating heating calc. Expand these points. And we take our temperature into there, and then we want some more blocks here that can be changed, so duplicate that and min OAT, and views AX slot sheet. Let's take out all these, so we'll hide them. Config flags, hide them, and we'll take out in 10 because it's a set point, and put that there, and because it's a set point, rename underscore SP, and then duplicate that, a maximum, again set point. So let's say outside air action set is at 25 degrees, and action set 3 degrees. So put that into there, put that into there, and then we need to duplicate these again, duplicate, and we do max first, max heating temp, short for temperature, action set, let's do 70 for the moment, and duplicate min heating temp, so it's nice and warm outside, action set 40. So according to this, is 0 degrees outside, so we're at 70 degrees. So that's our heating set point, 70 degrees. Actions, emergency override, and we'll put it to being outside at 26 degrees. Our set point's now 40. And then if we put it at actions, emergency override, I don't know, 16 degrees outside. our set point's 52.3. I think I'm going to up that to 80. That's gone to 56.4 now. Actions, emergency, auto. That is that done for that folder. That is our set point for our boilers. So let's composite that. Reorder, composite, outside air temperature in, and coming out our heating set point. And that's all we need to do there. Views, AX slot sheet, outside air, don't worry about that, heating, set point, and then we can rename this folder OAT OPT, outside air optimization. And then let's make it the same as that. Link mark, and I want the outside air sensor, which is here. Link to, out into there, and then that will go out to our boiler folder. So we've done a separate outside air optimization there. Right, got other things to do, but I've also got a conference call, so I'm going to put you on pause while I have my conference call. So while I was waiting for the meeting, I made another folder, but I have not done any logic inside it. So I've put the points in required for my inputs, and I've put in the outputs, and that's it. I'm just going to start another folder now, heating, and put my heating points in, and now I'm going to look at what my outputs are for the heating. IO, and we have on outputs that one, and boiler 1 enable. Boiler 2 looks like it's for the domestic hot water, 2 separate boilers, and we've got a heating override there, and that's it. So let's just add them points in there. So I'm just duplicating that, and that is RL heating pumps 1 and 2, and that's going to be a percentage, and then we have got our boiler 1 enable, duplicate, enable boiler 1. Do we want to enable boiler 2? I'm not sure what it's piped up hydraulically, so I think we will still do an enable boiler 2 just as belt and braces, but maybe it's not hydraulically connected that way. And we've got heating override valve as well. Duplicate, heating override valve, put that in there as well. So let's go through and take out all the histories on all the points. So we don't need that. We don't need them. So let's delete them. And we don't need them. And we don't need that. And we don't need that. And space, temperature, history. And take out that. And take out that one. And enable boiler 1. Remove. 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 Right, so now we can do the composite of these. You actually don't need to close these down. I just like it for neat and to be neat and tidy. Composite and safety. That's an in. That's an in. That's an in. That's an input. Universal input. Universal input. Universal input. Universal input. That's an output. This one's an output. Output. And an output. Go OK. Views, AX slot sheet. Safety. Healthy. Heating. Pump status. Heating. Pump 1 volt. Control key C. Control key V, change that 1 to a 2. Header. Flow. Heating. Flow. Space, temperature. Heating return. And then these are my outputs, so RL, raise lower, heating, pumps 1 or 2, enable boiler 1, enable boiler 2, heating valve override. So let's also take out these words now here. We don't need all that lot before it. We just keep with that. Rename. We don't need all that. Rename. Rename. Take out that. Take out heating flow. Start of it. UI05 remove, and UI08 remove. Link mark, go to our I/O. First of all, let's just see if there's anything. Heating pump status, link to, out, heating pump status, into there. Heating pump fault, link to, heating pump 1 fault, heating pump 2 fault, and then forget that, that's not that. Header flow, heating flow, space temperature, and heating return. And then we've got heating override valve, link from, output, heating override valve into there, and boiler 1 enable, link to, out, oops, link from, not link to, link from, boiler 1 enable, into there. And we've also got we're missing the nib here, so I know that we haven't done the heating pumps 1 and 2. Link from, heating pumps 1 and 2, 1 or 2, into there. And then we will take our safety and put it into there. So that's our safety done. But what we needed to do, which you haven't done, is our heating set point. So I'm just going to go into there. I'm just going to take that, copy it, go back 1, go into there, paste it into there, heating set point. At the moment I'll just put it down there and move it around in a bit. I'm going to composite that, composite, and bring that out, heating set point. And then I'm going to use this move up here to just take it up to the top, and while I'm in here I'm going to put heating return underneath heating flow. In fact, I might move that up to over the heating set point underneath header flow. Right, so that's done. So we need to just label that. Views, AX slot sheet, heating, OPT, set point, optimized set point. Maybe it should be OPTZ. And that should be rename OPTZ. And we take that set point and we put it into there. And I think that's all the I/O connected up, so we will check that now. So we go into the MAC36 folder and we check that all these have got something on the end of, and they have. Now our analogs, we're coming in there. That one we're not coming in, so we need to look at that. Domestic hot water or pump, so we're not coming in there. So we're missing remote alarm enable. So let's look at our domestic hot water. HWS and yeah, they're not there. So link market and add in link from HWS override valve into there, and that one link from HWS and then pump into there. So now that is correct. Yeah, that's in, that's in, that's in, that's in. We're not got no digital outputs. We're not using any digital inputs at the moment. And that is it. So that's our folders done. Now I've decided I'm not doing schedulers because it's feeding apartments, so it's going to be running 24/7. So there's no point in actually turning off the hot water when there's different apartments feeding from this. So we're going to leave that 24/7 running. Right, the safety is linked into the heating and the hot water. There's no safety linked into that, it's pointless. Frost protection is something that we need a set point for, because we've got the space temperature that we're monitoring. So let's just duplicate one of these and put fabric, not frost protection, fabric protection set point. And let's just put an underscore in there. And I wouldn't want the fabric to go anything less than 16 degrees. So let's set that to, let them go to 10 and let them go to 18. And we won't use decimal places. 5 to 18. They can set it to. Actions set. See all them others coming up, so we've got to do that as well. See these actions, emergency override. In fact, we'll do that now. Views, AX slot sheet. Highlight them. Config flags. Hide. OK. So now actions set is just set there now. I'm going to set that to 16 degrees. And because it's a set point, we don't need in 10 here on this particular one, and we'll just put a set there. So I know that's a set point. I know this is a set point, but this is a calculated set point. In fact, rename heating calc set point. Calculated from the outside air. So this one and this one we need to write logic for. So if the system goes below, mind you, if it's running, then, and there's nothing stopping it, what can we do? I presume we can put the heating valve on. We can enable both boilers, put a pump on. So let's do a T-stat here. So into our HVAC, under kit control, and we'll put a T-stat in there. Expand these pin slots. CV, SP and diff. Our control variable is that. Our set point is that, so that means that should be on. So change that to reverse, take off the null and put a diff in of 2, 1 degree either side. It is true because we are looking at minus in temperature. Actions, emergency override, put it to 18 and it's off. Actions, emergency auto, so we know that works. So that would want to start the heating override valve, and probably wants to override it fully open, and wants to start these fully open, and naturally wants to start a pump on as well. So we'll leave that as it is at the moment, and we're going to calculate on heating return, I think. So we've got our, I'll leave that as it is, sorry, leave that as it is. Let's just move that down one there. I'll take both of them, I'll just put them at the moment into a minimum block. So I want maths and minimum. Min temp, min heating temp. We'll put that into that, that into that. So we take the lowest temperature of them two systems, and that's our set point. Now that heating valve override is just on or off, 100% or 0. The same with the boilers. We're just enabling, they work on their own control. That isn't, that's either 5 volts or 10 volts depending on the pump. So we have got our heating flow and return into a minimum block here. So we can just work on a T-stat rather than a PI loop. But I do like PI loops, so I'm going to put a PI loop in there instead, even though we're just an on and off. So heating control, pin slots, set point control variable, loop enable, prop int. They're going to always be 0 to 100, but I'll still keep it there. So we enable with safety at the moment. We probably might change that in a bit. Our control variable is the minimum temperature. Our set point is our control with the outside air. And we'll put a 2 in the proportional and a 1 in the integral. And we would do a reverse because we are heating. Save that. So we're asking for 100% because we are cold outside, and the flow, not outside, sorry, the temperatures are in the minuses, and that's 80 normal. Right, so that is that done for now. So that's 100%, but we're going to stage this because first of all we need to put pumps on. Before we even put any boilers, we need to prove flow. So that's our very first thing we've got to do, is put the pumps on. Now that is a heating valve override, so I presume that needs to be on. A06 heating valve, that's got to be on. So we need that open as well. So we need these two things to happen, pumps and heating valve. So because we've got 100% there, we will put in there, we could do a sequence linear for the stages. and we can have a step between the stages of, say, a minute delay, that we could actually adjust ourselves. So let's just put in a set point here, duplicate, stage, delay, set point. And we'll change it to seconds, and we'll also set that so we'll go from anything from 5 seconds to 240 seconds. Need to set that to time and put that to seconds. Save, and I will set that currently at 60 seconds. Actions set 60 seconds. Now I need to times that by 1,000 because we want the answer. We want to be putting milliseconds into that. So maths, multiply sec to millisec. Put that into there. Times it by 1,000. And then take the output from that and put it into the delay, 1 minute. So there's the delay, 1 minute. So the first thing we need to do is we need to open up the heating valve. So we need to put that to 100%. So we go into our kit control, our utilities, and we do a numeric switch and heating valve. So the first thing that we do when the demand starts is that, and that needs to be 100. And then if it's not enabled, it is 0. This will also stage up with our 1 minute delays, the different processes. So that's that done. The next one is we want to run a pump. So we need to start a pump. So what we'll do here is I really want to run the lowest amount of run hour pump first, but I've only got 1 block, so I'm going to have to install new Boolean writable pump 1, enable, pin slots, take out in 16, and then add to that. So where are we? We are in heating, enable pump 1. In my kit control, go to my extensions and put a discrete totalizer in there, and then composite that out, and I only need elapsed time. Actions set to false, and then duplicate again, pump 2, and then I want to go into my HVAC and lead lag runtime, bring that across heating pumps, and then take my pump 2 and put it into runtime B, pump 1, put it into runtime A. My feedback is going to be that into there, and I'm going to start it with an in into there. Now we'll go in and give a 30-second feedback delay, a maximum run time. Definitely not going to be 6 minutes. I want hours, 24 hours. Change over every day. Save. So we're changing over 24 hours. And that is going to put that into there, and that into there, A and B, pump 1 and pump 2. Bring that up further there. And then we need to translate that pump 1 to be 5 volts. And that needs to be 10 volts, but in my case 50% and 100%. So duplicate, pumps. So that pump 1 is enabled. That's going to be 5 volts. And then duplicate again. Rename. Duplicate. Pump 2. That would be 10, 100, 10 volts. Save that. Take them, bring them down there. So that's switching them voltages. And they can go into a, because it's either one or the other, they're never both together, so that can go into a maximum block. Take the 50, take the 0 and put that into that there. That's that done. And then the third one is to enable boiler 1. Duplicate. BLR1. Third sequence there. Boiler 1. Into there. And then we'll have a boiler 2. Put that into there. That into there. And we'll do the sequencer linear, and instead of 3 we will now have 4. So we're staging up. And then the fourth one will be into there. So we start the heating valve, we override the valve. We wait a minute, as long as this is still climbing up. We then do the pumps, and from this one here, pumps, we wait again, and then we do boiler 1 after a minute, and we wait again, and we do boiler 2 if we can. So that views AX slot sheet. So A is valve open, pumps 1, or pump 1, not pumps. Boiler 1 go, boiler 2 go, and it staged itself off given a minute as well. That's still counting at the moment, it's minute, but that will sort that out. So that is our pumps done. So we've got our pumps, we've got our heating control. Right, we've got here pump 1 fault, pump 2 fault. So at the moment they are false being healthy. So let's put a NOT gate in there just for the moment. And FAU P1. Put that into there. Duplicate P2. Put that into there. So we've got a true signal. So we want to break that here. So let's just bring that across some more. We've got the pump enable there and a pump enable there. Let's just change that alarm as well to be feedback, clear alarm after 30 minutes instead of the hour. Because of the feedback not working, that's the reason why that's let's just enable that just for the moment. In fact, let's do it right at the control side, at the IO side instead of here. We have got it in there. Actions, emergency active. I can clear that now and that will work. So it's asking for pump A to be on. Now with pump A, so we need an AND gate in there. P1. Views AX slot sheet. Healthy. And enable. And then we can take that true for pump 1 into there, and we can take our enable into there, and because we're all happy we can start pump 1. As for pump 2, we can take that into our healthy and we can enable pump 2. And that into there. I could actually minimize these and make it a bit tidier, but I'm going to leave them as they are. Just drop that down 1 and drop that down 1. Leave it as it is. So that's our heating pumps done, linked with the fault. So if it is in fault, it won't start the pump. it won't start the pump. Then 30 seconds later, because we've got no DP, it would do the other. We could also add some extra logic in if we wanted to, using these. If it's in fault, we can also say that never try running that pump. So there's that as well, which we could do, which is using just a numeric switch. Let's just do that. Duplicate P1. No, let's do issue P1. Issue P1. Take that. Pump 1 switch in there. If it's true, no, it wants to be if it's false. Mind you, we could do, doesn't make much difference, we can do it the other way. We'll leave it like that. But I mean, I could use a false into there, but I'm only changing these. So true is good. So false. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Save. So what we do now is our runtime from this. We take that and we put it through this, and then we put that into runtime there. We delete that one, duplicate P2, take that, put that into there. I might take them out. Pin slots, take out that one. Pin slots, take out that one. Okay. And I need to take my runtime from that and put it into there, and take that and put it into there. So if I've got a faulty pump, so pump 1's faulty, actions, emergency active. We are now showing those amount of days it's been running for pump 1. So it's faulty. So basically the feedback should go off, but it's not doing because I've got it overridden. Actions, emergency auto. Actions, emergency auto. Oh, I've got it in the one overridden. Actions, emergency auto. So that's now moved to pump 2. Actions, emergency active. And if we was to do a start, so if I was to take off that in, so we stop it all, so none of them are running, I'm expecting pump B to start immediately once we actually do that, and pump B starts. Let's clear out the alarm just to show you that it wasn't just a fluke. Actions, clear alarm state, and then put it back in again, and pump B starts, because runtime A has got so many days running. So we're using the fault to basically also stop the lead lag runtime for enabling the pumps. Emergency auto. So that is all the I/O. Header flow not using, so that's just for information. I could actually put that into the minimum block if we wanted to, because we're only looking for the minimum temperature, so why not? There's no harm in it. Let's just take that out, and let's take that out, and pin slots C, and let's put in the header flow, the heating flow, and that flow. Done. So that's our control variable. We're ramping up, we're doing staging, valve open first, pump run, boiler 1, boiler 2, minute delay on, minute delay off. So we won't have any issues there. Safety, we'll switch everything off. So we go into safety, actions, emergency inactive, issue. Right, we still got the boilers because it's going through its 1 minute. So what we need to do there is put that into an AND gate before we switch them on. Not a problem. It's good that we check these. So heating valve, duplicate. Let's just duplicate it. I'm not going to name the slots. Pump start, that's the same as that, so we need to do something slightly different there. Duplicate boiler 1, duplicate boiler 2, put that into there. Oops. That into there, that into there, that into there, and that into there. And then that switch there, boiler 1, boiler 2, sorry, boiler 1. So that's going to go into there, that's going to go into there, boiler 1 into there, boiler 2 into there. Now the pumps, well, let's just do the heating valve, that's an easier one. So that true goes into there, and that goes into there. Now the pumps. We need to stop the pumps from running. Let's just make sure everything's okay. Emergency auto. That's going to start climbing up now. But we still need to do this. We need to stop. Because that's still going to have feedback there. It's the one. The in is from there. So we could actually just put an AND gate in there to stop it. And that will sort that one out. So that into there. Come out, delete that, and take that and put that into there, and that sort out the pumps for us. So when we have got, at the moment that's 100%, we're winding up, so we've got pump 1, still got boiler 1 and boiler 2, so we'll do that in a bit, and we'll come back to that one in a bit. Now that's done, it's just our hot water that we need to do now. So we have got buffer 1, buffer 2 temperature. Return is only going to be used really for that. Pump status, we're enabling the pump. So the first thing we need to do is we need to circulate the domestic hot water pump. So let's go into safety's healthy, those are healthy, and we're not running the pump at the moment, so we need a set point, don't we, for the buffers. So we can get a set point from here, and fabric set point there. I'll just take that, copy, paste, buffer 1 set point, and that's going to be anything from 60 to 70. Not that I think we'll be using that, but that's just irrelevant. We can change it so it's irrelevant. So we'll put that as 65. And then buffer 2. $65, and then we will go T-stats in our kit control. So T-stat, buff 1, pin slots, diff, buffer 1 control variable, buffer 1 set point, change that to a 2, change that to reverse, change that to false. That's that one done. Buffer 2, move that there, that there, duplicate, buff 2, that into there, that into there. So that's asking for it. Now the domestic hot water, let's do these high limit stats. Not gate, HL1, put that into there, duplicate, HL2, put that into there. So they're healthy. Our safety's there, so let's have an AND gate. Go buff 1, that's into there, and we're healthy with our stat, and we can put that into there. See, duplicate, go buff 2, let's just do our pin slots there, I'll just add in it to expose C, same with that one, views, pin slots, C, take that, put that into there, take that, put that into there, take that and put that into there. So that's go 1, go 2. That's our domestic hot water status there. So we've linked all them in. So pump status. So any one of them want to go, we want to enable the pump, which is a 50%, 5 volts. So we go to an OR. We're asking for it to run. So we will then need to do. So we've got the in there, and what I need to do now is give that 5 volts. So let's use a numeric switch. Numeric switch. Start pump. That's going to go in, and that's going to be 5 volts. But I need 50%. So I now give that 5 volts. Now when that's started, I'm going to get a signal back here to say it's working. We also need to put this to 100%. Duplicate. Open valve. Open valve. So we've got a demand. So we need to open the valve, giving it 10 volts. So we've now opened the valve. We started the pump, we've opened the valve. Do you want to delay before starting the pump or opening the valve, or do you want to open the valve first, have a delay and then start the pump? Won't do any harm, will it? So let's, first thing we're doing, we've got a demand, so we're going to open up the valve. Then we will wait a few seconds. So let's put a timer in there, Boolean, and we'll call that on delay. And that's going to be into there. We will wait roughly round about 1 minute. It's only an on delay, not the off delay. And then we start that. So that's going to go into there, and then we start the pump at 50 at the moment. Once we've got that back, and we've got a true from this, which is domestic hot water. Where are you? Domestic hot water pump status, actions, emergency active. So we've now got a true there. So once we've got a true, we can then move that to be 10 volts. So again, another numeric switch. Pump 1. That's our true in there. We then want to send out 100. If it's not true, we're going to send out a 5. Because we're going to link this now straight into there. So if we don't start pump, it's a 0. If we start pump, it's a 5. Let me show you this. Let me just take this off. Override, actions, emergency auto. So we're 5. We've started the pump, and then when we got the pump status back, I'll do it from there. We then start the boiler. Boiler 2. That's the logic done for that. The return temperature's just for monitoring. There's no well, we're trying to maintain 65 degrees on these buffers. I'm not bothered about the hot water return, long as I've got a value there for the graphic. So that is it all done. The logic, hot water and heating. There'll be probably other things that I find that I need to do, but we've covered all points. We know that if the safety goes, that's what we was going to do, weren't we? We was going to do the safety. So we have got all these stages up and running now. 100, 100, 100, 100. So let's now do the safety. Zero, 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 zero. Everything's off straight away. Yes, this is still counting down, but not bothered. It's gone off straight away, so that can count down as much as it wants to. As long as I am not giving an output out to them, I'm okay with that. So that's it. Thank you for watching, and I would appreciate it if you could subscribe. Thank you.